Invasive species are one of the greatest threats to biodiversity on Earth. The invasion cycle of introduction, establishment, and spread is intimately linked to human growth and civilization. In fact, one of the first places invasive species end up are cities. Cities and urban areas are hubs for human travel, trade, and transportation, and are consequently the setting for many invasive species introductions, both intentional and not. However, urban areas are notoriously difficult landscapes for many species to survive and navigate. For an invasive population to successfully establish and spread, they must first overcome the obstacles of city life. A classic example of an invasive species that has adapted to urban settings is the Asian tiger mosquito, Aedes albopictus. This is the most invasive mosquito in the world, and was introduced to the United States and other countries via the tire trade. The Asian tiger mosquito can now be found throughout much of the southern U.S., in cities, suburbs, and rural areas, despite having a limited natural flight distance. So how did it come to dominate the landscape? One way we can understand how invasive species like the Asian tiger mosquito travel through the urban landscape matrix is by measuring population gene flow and genetic connectivity. Using these tools, we can identify how different urban features may impede or facilitate their movement. Consider the urban-rural landscape gradient. Traditionally, we find native species are negatively impacted by urban landscape features, such as roads, buildings, and sidewalks. Thus, they are unable to move into urban settings. However, we hypothesize that the same features that inhibit movement along this gradient in native species assist the spread of the Asian tiger mosquito, so that it can quickly move across the landscape, for example, by using roads as corridors for dispersal. I am currently testing this hypothesis in Wake County, North Carolina. In summer 2018, I sampled 60 unique sites in Wake County that were representative of the urban-rural gradient, and I collected over 2,000 Asian tiger mosquitoes. Using these samples, I will characterize gene flow and genetic connectivity between the locations to understand how changes in landscape influence mosquito dispersal across a heterogeneous environment. These findings will be used to inform how cities and suburbs can responsibly expand to reduce the spread of invasive species. This is an important tool in the face of climate change that can aid local conservation efforts and preserve biodiversity.